Hello everyone. Today we're going to do the third and final review. I guess this is the final video for this course. Anyway, let's begin. Here we have a PMOS and we were given ID equal to 1 milliampere, VTP, Kp prime W over L, and the question says find RD in the triad region. Okay. Part B of the question says find the smallest value of RD while maintaining operation in triad region. Let's begin with part A. First of all, let's start labeling the circuit. So this is PMOS. This is labeled as VS, this is VD, and this is VG. Current here is ID, current here is also ID, and IG is always equal to 0 ampere. Anyway, so now we are looking for RD. I told you before that whenever the requirement is RD, just do Ohm's law, and from there you will know what to do. So RD is equal to VD minus 0 over ID. If you notice, we do not have a VD, but we have an ID, so we will keep it like this: VD minus 0 over 1 milliampere. How can we find VD? Now we can find VD through the equation of triad. The equation of ID in triad region is ID equal to Kp prime W over L VOV minus half VDS multiplied by VDS. Okay, let's substitute in numbers. 1 milli goes into ID. Kp prime W over L is 1 milliampere again, multiplied by VOV. We do not have VOV, or do we have it? Let's see. VOV is equal to VG minus VS minus VT. Do we have VG? No, we don't. Do we have VS? Yes, it's 5 from the circuit. Do we have VT? Yes, it's minus 1 volt. Okay, so we're missing VG. Let's see. How can we find VG? Notice here that we have two resistors and there's a voltage source, and we're looking for the point in between them, so we have to do a voltage division. So VG is equal to 5 multiplied by 2 mega plus 2 mega. This 2 mega is the one at the bottom always. The numerator is the lower resistance. Okay, so the answer here is 2.5 volt. 2.5. Hence VOV is equal to minus 1.5 volt. Okay, taking this number and plugging it in here, minus half, we do not have VDS, multiplied by VDS. Okay, so 1 milli with 1 milli, they cancel each other out. This becomes 1 minus 1.5 VDS minus half VDS squared. Half VDS squared plus 1.5. I'm taking these two parameters on the other side. Plus 1 equal to 0. After you use the calculator, if you go to mod, plus 5 plus 3, okay, you will get two values: VDS equal to minus 1 volt and VDS equal to minus 2 volt. Now we need one answer only. Which is the correct answer? In order to know the correct answer, you have to check. You need to check which region are we in. We are in the triad region, so you have now to check, does this number lead to a triad region, or does this number lead to a triad region? So the check for triad is VDS greater than or equal to VOV. VDS greater than equal to VOV. VDS is minus 1, VOV is minus 1.5, and here it's minus 2 is greater than minus 1.5. So minus 1 is greater than minus 1.5, but minus 2 is not greater than minus 1.5. Hence, VDS equal to minus 1 is the correct answer. Let's continue. Now, if VDS is minus 1, then VD minus VS is equal to minus 1. VS is 5 equal to -1, hence VD is equal to 4 volt. Taking 4 and plugging it in here will result in 4 kilo ohm, and this is the final answer for part A. For part B, find the smallest value of RD while maintaining operation in the triode region. Maintaining operation in triode region, what does this mean? It means edge of saturation. Okay, so we have to do the same thing again. Find RD but an edge of saturation. So RD is equal to VD minus 0 over ID. Do we have VD? No, we don't. Do we have ID? No, we don't. Okay. What do we know in edge of saturation? In edge of saturation, we know that VDS is equal to VOV. VD minus, let's expand it, VG minus VS minus VT. S and S, they cancel each other out. VD is unknown. VG, we computed through voltage division, and it does not matter on the region, it's 2.5. And VT is -1. So VD is 3.5 volt. Okay, we found VD. What's left is ID. Okay. Now ID, we will compute it through the saturation equation, because we said we are in edge of saturation. So half Kp prime W over L VOV squared, half 1 milli Kp prime W over L is 1 milli, and VOV is VG, it won't change. VG minus VS minus VT, VG is 2.5, VS was 5, and this is -1, and it will give you -1.5 volt. So -1.5 squared, and this will give us 1.125 milliampere. Plugging the numbers back into the main equation, 3.5 minus 0 over 1.125 milli is equal to 3.1 kilo ohm. Okay, so we're done with the first question. Second question. Okay, we have a nested MOSFETs, multiple MOSFETs. So what does the question say? It says find the mode of operation for each MOSFET, then find all the widths, the gate. I think they call it the gate width. Okay. So how do we start? We start by labeling each MOSFET. This is the most important part. So first, the Q1 is PMOS, Q2 is NMOS, Q3 is PMOS, Q4 is NMOS. So it's a mixture of NMOS and PMOS. Now this is VS4, this is VD4, this is VG4. This side is VS3, this side is VG3, this side is VD3, this side is VS2, VG2, VD2. This is VS1, VD1, VG1. I hope I didn't make a mistake. So let's start with Q1. You probably can ask yourself, where should I start, from Q1 or Q4? It doesn't matter. Okay, reason being, you see this current, even though it's on Q4, but the current here is similar to the actually exactly the current in here, and at the same time it's equal on all MOSFETs, so it doesn't matter where you start. Okay, so for Q1 we need to find the mode of operation. For Q1 it's PMOS, and in order to check for the mode of operation there, we need to check for VDS less than or equal to VOV. Let's open them. VD minus VS less than or equal to VG minus VS minus VT. S and S, they cancel each other out. So VD is, we're looking for VD1, S1, G1, S1, T1. VD1 is 0. G1 is minus 0.5, VT1 is, okay, here you have two possibilities, VT to be 1 volt and VT to be minus 1 volt, minus for P and positive for N. And because we are in PMOS, we're going to pick the minus 1. So here 0, is it less than 0.5? Yes, it is. Therefore, we are in saturation. Okay. So we found the mode of operation for Q1. Let's now find W1, the width of MOSFET 1. So ID is equal to half Kp prime W over L VOV squared. ID is 360 micro, equal to half 360 micro here. Okay. Half Kp prime is 120 micro. W is unknown. L1 is 2 micrometer. All lengths are 2 micro. And VOV is, now notice here that VOV is not equal to 0.5. Why? Because you have cancelled VS. If we haven't cancelled VS, then we can take this number and plug it in here. But now we're going to waste our time and solve for VOV again. Okay, so VOV is equal to VG minus VS minus VT. 1, 1, 1, VG1 is minus 0.5, VS1 is 2. I took it from here. It's the same thing, it's a wire. Okay, minus VT, which is minus 1. So VOV is minus 1.5 volt. Okay, minus 1.5 squared. And if you plug this into the calculator, you will get 5.67 micrometer. Now note that this is the width. Width should always be positive. If you get a negative answer, then this is definitely wrong answer. Okay. Now I want to teach you something which will speed your calculations or like save you time. Here we're no longer going to cancel VS, because sometimes or always we're going to use either VOV or actually both VOV and VDS into the ID equation. So we can just take these numbers and plug them in here. Okay, but we should not cancel VS. Okay, I did it only once to show you that how it will hamper us. Okay, so for Q2, we are talking NMOS here. So for Q2 it's NMOS. So VD, actually here you do not have to check. You know why? Because there's a connection. When there's a connection, then we are in saturation. So you can just say saturation because connection between VG and VD. Okay, so now we're done with the mode. Let's find W2, half Kn prime W over L VOV squared. ID is 360 micro. Half Kn prime is 240 micro. W2 is unknown. L2 is 2 micro. VOV we have to compute it. It's VG minus VS minus VT. 2, 2, 2. VG2 is VD2, which is 2. VS2 is 4 here. And VT T2, we're talking NMOS, so it should be 1. So 2 minus 4 minus 1 is minus 3 volt. Minus 3 squared W2 is equal to 0.67 micrometer. Okay, we're done with Q2. Let's go to Q3. We need to check, first of all, is it PMOS or NMOS? It's PMOS, so the check will be VDS less than VOV, less than or equal to VOV. VD minus VS less than or equal to VG minus VS minus VT. 3, 3, 3, 3, 3. VD3 is 4. VS3 is 8. G3 is 5. S3 is again 8. And T3 is, because we're talking PMOS, it's minus 1. So 4 minus 8 is minus 4. 5 minus 8 is minus 3 plus 1 minus 2. Okay, so is minus 4 less than minus 2? Yes, therefore saturation. After finding the region, let's find W. So ID is equal to half Kp prime W over L VOV squared 3. Okay, so this is 360 micro. Half Kp prime is 120. Yes, for PMOS 120 micro. W3 is unknown. L3 is 2 micro. VOV is, see, it has helped us, it's minus 2 directly squared. So W3 is 3 micrometer. Okay, let's do Q4. Q4, it's NMOS, so we have to check. The check for NMOS is VDS greater than or equal to VOV. VD minus VS is greater than or equal to VG. VS VT. 4, 4, 4, 4, and 4. So VD4 is 8. S4 is 13. G4 is 10. S4 is 13 and T4 is, I think it's NMOS, so it has to be 1. Yes. So 8 minus 13, that's 5 minus 5, and 10 minus 13 minus 3 minus 4. Is minus 5 greater than minus 4? No, not saturation. Therefore, try it. So the answer is try it here. So we have to find W now. ID is equal to Kn prime W over L VOV minus half VDS. Okay, ID is 360 micro. Kn prime W over Kn prime is 240 micro. W4 is unknown. L4 is 2 micro. VOV is minus 4. Minus half VDS is minus 5. And again minus 5. Once you solve this, you will get 0.4 micrometer. This question is simple, but it's very long. Okay, by the way, I took minus 5 from here and minus 4, it's here. Okay, great. Let's move on. We need to find R. So what's the first thing that you have to do? Of course, assume saturation first, and then we will do Ohm's law. You will say that R is equal to, now this is PMOS, this is VS, VD, VG, ID, ID. So R is equal to 2 minus VS over ID. Do we have ID? No. Do we have VS? No. Let's try to figure it out. Now here we have VOV, but because we are in PMOS, VOV is actually equal to minus 0.7, and the same thing here. VTP, we are in PMOS, so it's minus 0.4. Let's try to open VOV. VOV is VG minus VS minus VT. That's minus 0.7. VG is 0 because it's grounded. VS is unknown. VT is minus 0.4. This end up with 0.7 and 0.4. That's 1.1. Yes, so it's 1.1 volt. Okay. We are left with ID. We can get ID from the equation, saturation equation, Kp prime W over L, VOV squared. ID is unknown, Kp prime is 0.1 milli, W over L is 10 micro divided by 0.18 micro, and VOV is 1.1 squared. This will give us 1.361 milliampere. Okay, 2 minus 1.1, 1.361 milli. This will end up with 661 ohm. Great. Next, find mode of operation and W's. Let's first begin by labeling the MOSFETs. This is PMOS. This is actually, all of them are PMOSs. Okay, so all of them are PMOS. This is VS4, VG4, VD4, VS3, VG3, VD3, VS2, VG2, VD2, VS1, VG1, VD1. Okay, great. So let's begin with Q1. For Q1, we will say that VD, because it's PMOS, it's VDS less than or equal to VOV. Is VD minus VS less than or equal to VG minus VS minus VT? 1, 1, 1, 1, 1. What's VD1? VD1 is 0. S1 is 0.5. VS1 is VG1 is minus 2. VS1 is 0.5. VT1 is minus 1. Okay, so is minus 0.5 less than or equal to minus 1.5? No. Therefore, try it. Okay, after we figure out that it's right, we have to find W. So it's Kp prime W over L, W4 or W1, VOV minus half VDS multiplied by VDS. Okay, so ID is 360 micro, Kp prime is 120 micro, W1 is unknown, L1 is 1 micro, VOV is minus 1.5 minus half VDS. VDS is minus 0.5 multiplied by minus 0.5. and this will give us W1 equal to 4.8 micrometer. Okay, that's W1. Q2, we need to find the region, and the region is saturation directly because of the connection. So just say saturation because connection between the VG and VD. Okay, so we need to find WD. W2, it's half Kp prime W over L VOV squared. ID is 360 micro. Half Kp prime is 240, I guess. No, it's 120. Yes. Multiplied by VOV. We do not multiply by W2 over 1 micro. Yes. Multiplied by VOV squared. Now VOV we have to compute it. It's VG minus VS minus VT. 2 VG2 is 0.5. S2 is 3.5. T2 is minus 1. And this will give us minus 2. Okay, minus 2. So W2 will end up with 1.5 micrometer. Okay, Q3. Let's check the region. They are all PMOS, so it's VDS less than or equal to VOV. Is VD minus VS less than or equal to VG minus VS minus VT? 3, 3, 3, 3, 3. VD3 is 3.5. VS3 is 6. G3 is 2. VS again 6. VT is minus 1. Okay, so 3.5 minus 6, that's minus 2.5. 2 minus 6 minus 4 plus 1 minus 3. Okay, so is minus 2.5 less than or equal to minus 3? No, therefore it's triode. Let's find now. WID is equal to Kp prime W over L VOV minus half VDS multiplied by VDS. ID is 360 micro. Kp prime is 120 micro. W is unknown. L is 1 micro. We're finding W3, right? Yes. Multiplied by VOV. VOV is minus 3 minus half minus 2.5 multiplied by minus 2.5. So W3 is equal to 0.68 micrometer. That's Q3. Let's do Q4 now. Q4. It's PMOS, so VDS less than VOV. VD4 minus VS4 less than VG4 minus VS4 minus VT4. VD4 is 6. S4 is 10. G4 is 6 minus 10 minus 1. 6 minus 10 is minus 4. 6 minus 10 minus 4 plus 10, 6. So is minus 4 is minus 4 less than 6? 6 minus 10 is minus 4. Minus 4 plus 10. Yes, I guess it's right. Okay. So is minus 4 less than 6? Yes, it is, therefore saturation. Okay, let's find ID now. Half Kp prime W over L VOV squared. ID is 360 micro equal to half 120 micro W 4 over 1 micro multiplied by 6 squared. I think it's wrong. I want to double check. VG is excuse me 6, VD is 6, correct? Yes, VS is 4. 6 minus 10. You know why I'm thinking there's something wrong? Because VOV has to be minus. I got 6. Interesting. I guess I will continue with this. If there's something wrong, I will update you. But it seems correct. Unless I have copied the numbers wrong. But I will update you later. Anyway, let's continue with this. So 360 VG minus VS oh, I know what's the mistake. VG minus VS minus T. What's T? T is minus 1. I don't know why did I put minus 10. I guess probably you have caught the mistake before me. Anyway, so I was right actually that this shouldn't be 6. It should be a negative number at least. So 6 minus 10 is minus 4 plus 1. It's minus 3. See how I caught a mistake? Because this is PMOS, right? PMOS, the V's has to be negative. Voltage drops, they have to be negative. So VOV has to be negative, and I got a positive number, so there was something wrong. Anyway, so W4 here, it's equal to 0.667 micrometer. Okay, great. Next. Again, more than one MOSFET. So the first thing is to label them. All of them are NMOS. NMOS. Now if you notice here, there's resistance. There's a resistance in the middle. It won't complicate things. It's still easy. I will show you how to solve it. This is VD1, VS1, VG1, VD2, VS2, VG2, VS3, VG3, and VD, VS3, and this is VD. Okay, let's begin with Q1. Here they did not ask for the mode of operation because they are all saturation, and they asked for R also. R is at the bottom. Anyway, let's begin with Q1. It doesn't matter where you start, by the way, Q1 or start from Q3. Let's begin with Q1. We need to check for the region. So for Q1, we have to say that no, there's no need to check for the region, I forgot. So just let's find IW W1. ID is equal to half Kn prime W over L VOV squared. ID is 100 micro. Yes, half Kn prime, it's 100 micro again. W1 over L1, 1 micro, and we need to find VOV. VOV is VG1 minus VS1 minus VT1. So VG1 is 10, VS1 is 8, VT1 is 1. So 10 minus 8, 2, 2 minus 1, 1 volt. Okay, so 1 squared, this will give us W1 equal to 2 micrometer. Okay, Let's move on to Q2. Same thing, saturation, half Kn prime W over L VOV squared. ID is 100 micro, half Kn prime is 100 micro, W2 over 1 micro VOV squared. What's VOV? VOV is VG minus VS minus VT. 2, 2, 2. What's VG2? Now VG2 is here and it's unknown. It's not equal to 8. Why? Because there's a resistance in here. Okay, so what can we do? If we have a current 100 micro and we know one of the sides, how can we get the other side? Ohm's law, right? Okay, so we will say ID2 is equal to 8 minus VD2 over the resistance, which is 10K. ID2 is 100 micro, 8 minus VD2 unknown over 10K. So VD2 is equal to 7 volt. Okay, so 7 minus S2, S2 is 4 and T2 is 1. 7 minus 4, that's 3 minus 1, 2 volt. Okay, so 2 squared is equal to, W2 is equal to 0.5 micrometer. Okay, we found Q2. Let's find the last one, Q3. Okay, so ID is equal to half Kn prime W over L VOV squared. ID is 300, no, it's 100 micro, half 100 micro again, W3 over 1 micro multiplied by something. This something we have to find out. VG minus VS3 minus VST3. Okay, so VG3 most probably it's unknown. Yes, it's unknown. We can find it through Ohm's law. It will be 4 minus something over 10K. So it's 10. I forgot. It's 4 minus, no. It's 4 minus VG3 over 10K. This is 100 micro, which is I. So VG3 is equal to 10K multiplied by 100 micro. 10K multiplied by 100 micro. 10K 100 micro. 4 minus 1, 3 volt. Okay, so it's 3 minus S2. S2 is no, it shouldn't be S2, it should be S3. So S3 is 1 and T is 1. 3 minus 2, it's 1 volt, so 1 squared. W3 is equal to 2 micrometer, as simple as that. Last requirement is to find R. R can be found through Ohm's law. It's 1 minus 0 over 100K, the current, okay, which is equal to 10 kilo ohm. Okay, simple, right? Next, that's an amplifier. So how do we begin? We begin by killing. So the first step is kill AC, keep DC. Okay, the only thing that we have to kill is this, so it will be 10 3.6 kilo ohm .4 volt, and that's it. So step number 2 is to calculate VO, and VO is always on VD. here. This is VD equal to VO. Okay. So here in amplifiers we are always in the saturation region. There's no need to check or assume. Okay. Then what can we do? We can utilize the ID equation Kn prime W over L VOV squared. ID is, what's ID? No, we do not have ID. Okay, so half Kn prime is Kn prime with W over L is 1 milli. VOV squared is, we do not have it, let's compute it. Vg minus Vs minus Vt. Vg is 4 here. S is 0. And T is 2, which is equal to 2 volt. So 2 squared, this will result in 2 milliampere. Okay, after finding VD, ID, we can find VD through Ohm's law. So we can say ID is equal to 10 minus VD over 3.6K. VO, it's equal to VD, which is equal to 2.8 volt. Okay. Next, step number 3. Calculate GM. The equation of GM is, one of the equations, it's 2ID over VOV. 2 multiplied by 2 milli over VOV, which is 2. Yes. So it's 2 milli A over V. Third step, kill DC, keep AC. Okay. And the fourth step, replace. So how will the circuit look after killing DC? We have to kill this and keep the AC. So it will be as follows. Resistance of 3.6K MOSFET, and here it's grounded, and we have only the AC source V sig. Okay, let's replace now. We need the small signal. How does the small signal look like? We have a current source GM, VGS, and here we have the D, ID, and here we have IG equal to 0 ampere. This is VGS, G, and this is SID. Okay. Great. So let's start connecting the missing points. S is grounded, D has a resistance and then ground, 3.6 kilo ohm and then ground. On G there's a source, V sig, sorry. Okay, and now it's time to find V output. V output over V sig, correct? Yes, V output over V signal. So where do we start? We start from V output. We say that V output is equal to minus ID multiplied by 3.6K. And then ID is equal to GM VGS. VGS is equal to, it's equal to V sig directly. Because there's an open circuit, this point is V sig and this point is 0. So you can just say VGS is equal to VGS plus minus VGS plus minus VGS minus, this is V sig, and this is 0, so it's V sig. Okay, so you go back, GM V sig, go back, it will be minus GM V sig multiplied by 3.6K. we're looking for VO over V sig, so this will become minus GM 3.6 K. GM is 2 milli multiplied by 3.6 K. K with milli, they will cancel each other out. Okay, and the answer will be minus 7.2 volt over volt. Okay, that's first part of the question. The second part, we have to draw the waveform if V signal, V input or V sig is 100 milli peak. See here, this is very important. Peak to peak, it's 100 milli. Draw the output voltage waveform. Okay, so let's isolate it. V sig, it's equal to 100 milli V peak to peak, and it's 50 millivolt peak. Okay, we're looking only for peak values, and we need to draw the output waveform showing AC and DC. Okay, now the DC component of the output, it's 2.8, and for AC, V output over V sig, it's equal to minus 7.2. So V output is minus 7.2 multiplied by 50 milli. Okay, so the answer is 0.375 volt. Okay, so first we have to go to the offset, which is 2.8. We need to start from bottom because the output is negative. Okay, what's the peak value? We need to figure it out. What's the minimum value? We need also to figure it out. So what we're going to do, we will say 2.8 plus 2.8 minus the AC component, 0.375. Okay, the answer here is 2.4. There's a minus here, I forgot about it. 2.425 volt, and here it's 3.175 volt. Okay, so the maximum is 3.175, minimum is 2.425. Okay, that's it. Next question, amplifier again. Let's begin. First step, kill AC, keep DC. Okay, we have to kill only this, so it will look like the following: 1.8 volt, 17.5 kilo ohm, here we'll kill the AC, keep only DC. It's equal to VGS, and VGS is 0.6. Let me write it directly, and here it's grounded. Okay, second step, calculate V output. We said we are in saturation. Okay, let's find ID first. Half Kn prime W over L VOV squared. ID is unknown. Half Kn prime is 0.4 milli. W over L is 10, and VOV squared, it's Vg minus Vs minus Vt. Vg is 0.6 minus 0 minus Vt, which is 0.4. Okay, so it's 0.2 volt, which is equal to 80 microampere. This is ID. After finding ID, we need to find Vd through Ohm's law, or V output. So ID is equal to 1.8 minus Vd over 17.5 K. So V output is equal to VD, which is equal to 0.4 volt. This is the answer. Okay. Question 3 or part 3. Calculate GM. GM is equal to what? GM is equal to 2ID over VOV. 2ID is 80 micro over VOV, which is 0.2. This will result in 400 micro A over V. Okay. Step number 4, kill AC, keep DC. Opposite, kill DC, keep AC. 5, replace. Okay, let's draw it again. This is grounded. We have a resistance 17.5 kilo ohm, and then only the AC source. Basic, yes, and here it's also grounded. Let's now draw the pi model. This is ID, this is D. Here we have GM, VGS, this is VGS, this is S, and that's ID again, and here it's IG equal to 0, never mind, and this point is G. Okay, let's connect the missing parts. On D we have a resistance and a ground, 17.5K. This is the output, this is grounded, and here we have a voltage source V sig. This is very similar to the previous question. So step number 6, find VO over V sig. Let's begin. VO is minus ID multiplied by 17.5K. ID is equal to GM VGS. VGS is equal to V sig. GM V sig. ID GM V sig 17.5K. So V output over V sig, it's equal to minus GM 17.5K. GM is equal to 0.8. No, GM is 400 micro, right? 80 micro multiplied by 2, 0.2. Actually it is 0.8. What happened here? V of is 0.2, correct? Yes. So this is 0.8 milli. Okay. So here minus 0.8 milli multiplied by 17.5K, which is equal to minus 14 volt over volt. Okay. Now we have to draw the waveform. V input is 5 milli. Okay, we need to draw the output waveform. So time V output, let's see, AC, or let's begin with DC. DC is equal to V output, it's equal to 0.4, and for AC the output is equal to minus 14 multiplied by 5 milli, and it's equal to minus 14 multiplied by 5 milli. Yes, minus 14 multiplied by 5 milli, it's equal to minus 0.07 minus 70 millivolt. Okay, so 0.4 plus minus 70 milli, and 0.4 minus 70 milli. This will give us 0.4 plus or minus 0.7 milli, 0.399, and 0.4 plus 70 milli, that's 0.47. Okay, so we need to start from the first offset, which is 0.4, then start from the bottom, go up. Maximum peak is 0.47, minimum is 0.399. 0.399. Okay, good. Sorry, this is wrong, it's 0.33. Great, next question. Find RD in saturation mode, find RG1. So RD we have to do Ohm's law, it's already in saturation. So RD is equal to VD minus 0 over ID. This is VD, this is VS, PMOS, VG, and ID. Okay, so do we have VD? Yes. Do we have ID? Yes. So it seems the first part is extremely simple, and that's 6 kilo ohm. Okay, that's for part A. Let's go to part B, which says find RG1. To find RG1, okay, RG2 is given. RG2 is given to be 2 mega. I forgot to write it down. So in order to find RG1, what we can do is we can do voltage division. But in order to do that, we need VG first, and VG is unknown. We usually get VG from VOV, because VOV is VG minus VS minus VT. VOV is also unknown, but we can find it from the ID equation. And because we are in PMOS, saturation, we will write down the saturation equation. So ID is 0.5 milli, half, Kp prime is 1 milli with W over L, VOV is missing. So VOV, it's equal to 1 volt, and VOV is equal to minus 1 volt. Which one are we going to pick, positive or negative? Of course we're going to pick the negative, because we are PMOS, right? Okay, so if VOV is minus 1, VG unknown, VS is 5, VT is minus 1. So VG is equal to 3 volt. After finding VG, that's part B of the question, this is part A. After finding VG, we can do voltage division. We can say VG is equal to 5 multiplied by RG2 over RG2 plus RG1. Yes, RG2 over RG2 plus RG1. Great. So VG is 3. This is 3. This is 2 mega. This is 2 mega again. So RG1, you will end up with 1.33 mega ohm. This is mega. Okay, next. So all 3 MOSFETs are of type N. They are NMOS. This is VS3, VS3, this is VD3, this is VG3, VG2, VG1, VS1, VD1, VS2, VD2. Okay, so we need to find only the width for each MOSFET. Let's begin with Q1. They are all saturation. So ID is equal to half Kn prime W over L VOV squared. ID is 260 micro. half, Kn prime is 120 micro, W1 is unknown, L1 is 1 micro, VOV is unknown, let's find it out. VG minus VS minus VT, VG is 1.5, S1 is 0, T is 1, which is equal to 0.5 volt. So 0.5 squared, this will end up with 17.3 micrometer. 17.3 micrometer. Okay. Q2, we'll do the same thing. ID is equal to half Kn prime W2 over L2 VOV squared. 260 micro, half 120 micro, W2 unknown, 1 micro here, and VOV is unknown, let's find it out. VG minus VS minus VT, 2, 2, 2, VG2 is 4, S2 is 1.5, and T2 is 1. The answer is 1.5 volt. Yes, so 1.5 here squared, W2 is equal to 1.93 micrometer. For the last one, Q3, ID is equal to half Kn prime W3 over L3. This is very simple. There's no tricks in it. Straightforward. So 260 micro equal to half 120 micro, W3 is unknown, 1 micro in here, VOV squared, VG3 minus VS3 minus VT3. So G3 is what? 6, S3 is 4, T3 is 1. 6 minus 4, 2, 2 minus 1, 1 volt. Okay, so 1 squared, W3 is equal to 4.33 micrometer. And I guess we have concluded the third review and the final video of this course. Thank you for listening, and I hope you have understood and learned from me.